Hi, my name is Afifa Ayuni. We are from Group 7. We will present about conservation of momentum. Let's start this presentation with the introduction of this topic. First, what is conservation of momentum according to the general of law physics? Conservation of momentum is a quantity that called momentum characterized motions that never change in any isolated collection of an object, and this total of momentum in a system will remain constant.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ilana Najwa binti Azlah and my metric number is AA210339. Next is the theory about conservation of momentum. The total momentum is the sum of the individual moment for several objects, both direction and the magnitude of motion involved, so that the total of moment is zero, since the moment of object is going in opposite direction, that make the moment is zero. The sum of the two moments after and before collision is equal in a collision of two particles, so that if one particle of momentum lose, the others one will gain. Next is the history about conservation of momentum. The first right statement of the law of conservation of momentum was by English mathematician John Wallis in 1617. His sentences are: the initial state of the body, either of rest or of motion, will persist, and the other one is, if the force is greater than the resistance, motion will result. In his definition too, it defines quantity of motion as arising from the velocity and quantity of matter conjointly, which identifies it as a momentum. He refers to mutation motors, or we call it change of motion. It's being proportional to the force impressed. Automatically, it's momentum and not a motion. That's all from me. I will pass the next part to the next presenter.
Hi, my name is Wan Ani Zikri bin Wan Yusri from section 6. I want to present about physics before momentum of conservation before shooting. Firstly, a gun has a bullet mechanism. Before shooting, the bullet in the guns are equal to zero according initial velocity formula. And second, the bullets move depend on the trigger that we pull in the gun. So that means in my explanation is when before we shoot, according to the formula, initial velocity formula, the bullet is zero because they doesn't move anything until we pull the trigger at the guns. Okay, so that's it. Thank you. Bye bye.
Right, I will talk about the point after the shooting. I need already said about the shooting here. So I will talk about the after the shooting. It's about the recoil and the bullet. So when the system evolves, one feature of the system stay remain. This why we call it momentum potential. As an example, different initial reference frames to assign a different value of power to the system linear momentum. So you said that in the gun, when the one system is evolved, so the other one is still remains, is the bullets will move in the linear momentum. So if the power is zero, the value of power is still constant, while other particles move around. That's the bullets. So if the F external is equal to zero, the internal observed are equal. So if external is zero, so the inertia will are equal. So the sum of the initial force is being equal and opposite, produce equal and opposite change in momentum, which cancel each other. So that was we call it momentum potential. This all for me. Thank you.
advantage for conservation of momentum. First, pile and hammer. As a result, the hammer momentum can be transferred to the piles at the same time, producing the force to push the piles into the ground to do construction work. Next, as the hammer is released from the one head, it can easily push the pile into the ground. And when the hammer touches the pile, it can generate a lot of momentum. Okay, next, flight takeoff. After action in momentum, the plane was able to take off from its runway and fly into the sky. Because of the momentum change, the plane lifting power increased when an aeroplane departs from a runway with a set speed limit.
As a conclusion, the conservation of momentum theory is obviously all around us, and there are several applications and benefits. It can also be used to any circumstance such as engineering and equipment. This idea applies when there are moving objects with velocity and a mass. The mass and the velocity of an object determine whether it has a large or small momentum. Moreover, momentum and momentum impact can be decreased and maintained. This hypothesis is evident in the presence of specially constructed cars with several safety features such as belts. In addition, the front and rear of the car, which are made of easily crushed material, also reduce the momentum in event of an accident. Another safety feature found on the vehicle is the body of the vehicle is made of a steel and not easily crushed, which can prevent passengers from being hit by external force directly. Last but not least, the theory of conservation of momentum really exists and is used in daily life as well as for industry use.